Dear students, now let me solve this question. Okay, so here the question is, determine the maximum acceleration of the train in which a box lying on its floor will remain stationary. And here given that the coefficient of static friction between the box and the floor of the train is 0.15 and g is 10 meter per second square. So first let me understand the situation. Okay, suppose this is a train, suppose this is a compartment of train. Okay, suppose this is a compartment of a train. Okay, this is a compartment, suppose, and a box is a box. Okay, a box lying on its floor. Let me draw over here. So suppose this is the box. Okay, so the box of mass m, suppose. Now when the train will be moving along this direction with an acceleration a, suppose, then what will happen? This blocks wants to move backward direction, along backward direction. Okay, when the train will be in motion along forward direction, at that time the block wants to slip backward direction. Okay, so what will happen if you see it separately? So let me see it separately with free body diagram. So what will be the forces acting on this object? So mg downward direction along and normal direction in. Okay, now here is a frictional force will act. What will be the frictional force? Now as well as the block like to move in backward direction, along backward direction, then a frictional force will arise here, and the frictional force will be of course opposite the relative motion of the block. So the block wants to move backward direction, so the frictional force will act along forward direction. Okay, now if the block will remain stationary, then this F should be equal to mass into acceleration, because what is the force acting due to this acceleration? The force acting due to this acceleration on this block is mass into acceleration. F is equal to ma. So F is equal to ma. So this F should be less than or equal to this. Okay, then only the block will be at rest. So at extreme level, when this F will be FL, okay, F will be FL, then in that case this FL, if we talk about FL at maximum level, that is that limiting friction, then this FL will be equal to this ma. Okay, so at critical condition you can say, at critical condition you can say that this force will obviously less than equal to FL. Why this is less than equal to FL? Because if this is greater than FL, then the block will be moving forward direction. But we have to find out here the situation when the block is stationary. So the block will be only stationary if this FL is equal to or ma or less than ma. Okay, so ma should be like this. So the FL should be less than equal to ma. Okay, so in that case A should be ma should be less than equal to FL, means mu s into g. Okay, so A will obviously less than equal to into m, because let me here n is equal to mg. Okay, and that FL is equal to what? Mu s into n. FL is equal to mu s into n. So FL will be mu s mg. So it is just mu s mg. Okay, so what will be the acceleration, the maximum acceleration? So A will be here, A is less than equal to mu s into g. So the maximum acceleration will be mu s into g. So A should be less than equal to mu s into g. If A is greater than this, then this frictional force cannot resist the object at stationary. Okay, so if ma is greater than FL, then the block will be moving along upward direction, along forward direction. Okay, so in this situation here from this inequality we can easily say that the maximum acceleration is mu s into g. Okay, so what will be the magnitude? If we put the value, then we will get, so a is less than equal to mu s into g, that means a max, maximum acceleration is mu s into g. So mu s is what? 0.15 into g is 10, so that means 1.5 meter per second square. Okay, so this will be the answer to the problem. Thank you.